So this video actually covers the extension for 5.1 as well as 5.2, and there's only two things that I want to mention for this extension. So a relation is slightly different than a function, okay? A relation pairs inputs with outputs, okay? So a relation pairs inputs with outputs. Basically, this one includes more things. However, a function is more limiting because every input has only one output. Okay? And what that means is that if you take x, let's say 1, and you plug it in, well, according to this, you could get -7 or -5. Well, if you graph those 2 points, then they're both going to be on top of each other. And so what I want to show you is that in order to be a function, a line has to pass the vertical line test. Okay, so a graph represents a function when no vertical line passes through more than one point on the graph. So if you take a vertical line and you draw it through any function, it will only ever touch at one point. Here, it actually touches down below and up top. So this is not a function. This is a relation. So we're going to look at a couple of graphs. And we're going to use the vertical line test to determine whether or not it's a relation or function. Okay, so if I draw a vertical line anywhere, oh, right here, this one would touch 2 points, here and here. So this is not a function. Here, if I draw any vertical line, it's only ever going to cross through one point. Therefore, this is a function. So if I draw a vertical line, I'm only ever going to hit one point. We're good. Vertical line, I'm still only ever going to hit one point. We're fine. If I draw a vertical line through most of this, I'm going to hit 2 points. Top and bottom, top and bottom, top and bottom. So of these three, the only one that's a relation is this. And these two are actually functions, okay? All right, so that's for 5.1. Go ahead and turn to 5.2. And we're going to talk about discrete and continuous domains. So we know that the domains are the inputs or the x values. Discrete or continuous. Okay, well, continuous means that it's continuous. It's all numbers between and the endpoints. So any of the graphs that we've been doing, anything that has a line has been continuous. We're going to talk a little bit about the discrete ones because these are more like the case when we're talking about real life situations. So we talked about how you can sell children's tickets and adult tickets, okay? And our domain, we're just a list of numbers. Same for the range. Whereas here, it's a solid line, so I could pick any point on this line and it would work. Okay, because we can sell parts of a pound of cheese, either Swiss or cheddar, doesn't matter. But we don't necessarily need to sell whole pounds or half pounds or things like that. Whereas up here, when we're talking about this, we have just specific values that we can sell. Nothing in between would work because we would end up selling half of a ticket. So this is discrete, and this is continuous. That's the difference between discrete and continuous domains. So I want you to go ahead and take a look at these and try to figure out which one would be discrete and which one would be continuous. Okay. So in this one, you are in charge of reserving hotel rooms for a youth soccer team. Each room costs this plus $6 in tax. You need each room for 2 nights. You need 10 to 16 hotel rooms. We want to write a function. Okay, so For this, we need each one for 2 nights. So we end up with y equals 150x. So in our domain, we could have 10, 11, 12, 13, 14, 15, or 16 rooms. Okay, these are the rooms, which is my discrete domain. My range would also be discrete because I'm plugging in specific numbers. Here we have a luggage weight, and this one says that you're determining that there's 36 pieces of luggage and each piece will weigh from 25 to 45 pounds. Okay, well, so we've got y equals 36 times x, okay, because there's 36 pieces of luggage, and this is going to be our weight. Well, our weight is an inequality. It's between 25 and 45. So because there are many different numbers between these, this is continuous. It doesn't have to be exactly 25, 26, 27, 28. It could be 25.1. It could be any number between these two. Therefore, it is a continuous domain. That's it for today. Let me know if you have questions in class.